The last thing I want to tell you guys about this is for a group O individual, we were able to determine their blood type by a lack of a reaction. So group A and group B are easy to determine because we can see a positive, and group AB is easy to determine because we can see a positive reaction. But for group O, by there being a lack of a reaction, it's like a process of elimination. So if they didn't react with anti-A and they didn't react with anti-B, that means that they must not have any ABO antigens on the red cell surface. So that's good enough for us. We don't have to take anti-H and test every single group O person that comes up, because 99.999% of people have that H antigen, even if they're group O. They'll just be coded with H antigen. If you can't just assume that they're all going to be Bombay, because there's very, very, very few people in the world who are actually Bombay. So little that it's negligible. So we're not going to take an anti-H antibody, like an anti-sera. We're not going to take the anti-H and confirm all of our group O's and just make sure that they have the H antigen. That's not something we do. The only thing we do for group O is we just, by a process of elimination, if they didn't react with anti-A and they didn't react with anti-B, that must mean that they do not have any AB antigens on the red cell surface and they're group O. If they truly are a Bombay individual, they will have a lack of that H antigen. They only have the precursor substance. They weren't able to convert their precursor into the H antigen, which means they could not possibly have A or B antigens or the H antigen on their red cell surface. And so by nature of that, if they are Bombay and they do lack all of those antigens, they will have naturally occurring, they'll have in their plasma anti-A, anti-B, and anti-H. Nobody in this world has anti-H unless you are Bombay. Okay, now I have to say an exception. Or if you're group A1B, if you're group AB, but it's in the A1B form, you convert so much of your H antigen that your body might think that the H antigen is foreign and you have the ability to actually produce an anti-H. So don't completely quote me on that only Bombay individuals can produce an anti-H, because technically a group A1B individual could, because they convert so much of their H antigen into the other two antigens that they don't even recognize the H as their own anymore. And they have the ability to produce an anti-H antibody. But otherwise, if you're Bombay, you have anti-A, anti-B, and anti-H in your plasma. And that is really important to determine, because if they have an anti-H in their plasma and you were to cross-match them, like give them group O blood, because you're assuming they're group O, right? If they're Bombay, they can't produce any they can't produce any antigens. So they appear to be group O. If they can't produce any antigens, and I just told you, how do we determine a group O person? Well, if they don't react with anti-A and they don't react with anti-B, they must be group O. And we don't confirm with anti-H with all of them. But technically, a Bombay individual, they will present the phenotype of group O. That's the phenotype that they're going to present. That's what we would see on the red cell surface by the process of elimination of not having anti-A or anti-B. So I know we don't actually see the group O, but the way we do see it is by a lack of reaction here in the anti-A and anti-B. Their phenotype, group O phenotype, presents like this. So the phenotype for a Bombay individual is also going to present like this, with a negative reaction and a negative reaction in the anti-A and anti-B. So the phenotype of a Bombay is going to look like group O, but technically, genetically, they don't have the A or the B or the H antigens on their red cell surface. And so if we were to type a Bombay person and not confirm with the anti-H, we would say, okay, this person's group O. And we would just assume that. We wouldn't assume Bombay. And then we would take, if they needed a cross match, if they needed blood to transfuse into them, we would grab group O blood because that's what we thought their blood type was. So we would grab group O blood, but we would do a cross match. And I know we haven't talked about cross matching yet, but what a cross match is when you take the patient's plasma, and we know that the patient's plasma is where the antibodies are. So we would take patient plasma and we would mix it, just like these tubes here. It would be patient plasma with patient plasma with donor red blood cells. So it would be almost like this here. We would take patient plasma and we would actually mix it with not a reagent A1 cell. We would mix it with donor blood. What we're going to transfuse into the patient, the red cells, we would mix with the patient plasma. And that's our way of determining whether the blood would be safe. We would have their plasma, which it has the antibodies in it, and we cross match it with the donor red cells. And for a Bombay person, we're going to take group O blood because that's what we thought they were. But what do we know about group O blood? All of the 99.99% of people out there, group O individuals have H antigens on their red cell surface. So if we were to take the plasma from a Bombay person who have anti-A, anti-B, and anti-H in their plasma, and we mix it with donor blood of the group O blood type that have H antigens on them, the anti-H from the Bombay plasma is actually going to agglutinate and react with the group O red cells because they have H antigens on them. So that's our way of catching that's our way of catching a Bombay person. So if we missed it based on their blood type, like by doing a blood typing here and not using anti-H, we would, as a reagent, we would catch it in the cross match because we would take the patient plasma with an anti-H in it. And we didn't know that yet because we didn't test it up here. We only tested it would have been over here. We only had A1 cells and B cells. We didn't have H cells, like group O cells. So we wouldn't have been able to catch it with the patient's plasma. But we would in the cross match. We would take group O cells, we would mix it with the Bombay plasma, and that anti-H would agglutinate the donor red cells. And anytime we see agglutination in a cross match, we know it's incompatible. It's not safe to transfuse. So ultimately, that's where it would be caught, and that's how we would know to further investigate why is this cross match coming up incompatible. Let's further investigate, and then one of the options could be to test for it with the anti-H and see if they're lacking that H antigen on their red cell surface. And then we can take more group O cells. Instead of A1 cells or B cells, we could take group O and mix it with the patient's plasma and see if it comes up. In that case, it would come up positive because the anti-H from their plasma would react with group O cells.